Okay guys, I was just watching this 3 blue 1 brown video and it hit me.
And likewise, dividing functions doesn't really add anything, because that's the same as plugging one inside the function, 1 over x, and then multiplying the two together.
Do you see it? Do you see it? This is the origin of the quotient rule. When I saw this, I paused the video and just had to try it myself. And I want to show you guys where this mysterious formula for the quotient rule comes from. The quotient rule says that the derivative with respect to x of a function of x over another function of x is this entirely crazy long formula, which you've all remembered as the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared, right? But where did this come from? And I know this is pretty basic to some of you, but seeing this today really made my day, and I just had to write it out, and I want to try out a new format for making videos. So I thought I would try it out with like a simple concept like this. But where does this formula come from, right? This seemingly crazy looking formula. Where does this come from? Well, like 3 blue 1 brown said in his video, you can think of f divided by g instead as f times 1 over g, right? You plug in the second function into the 1 over x function. So let's just try that and see what comes out. So let me just clear this. Okay, so let's try it. So the derivative with respect to x of f of x over g of x equals the derivative with respect to x of f of x times 1 over g of x. Now we could rewrite this as the derivative with respect to x of f of x times g of x to the minus 1 power. That's the same thing as taking the reciprocal. So now we can see, well, I mean, it took me a second, but we can see that we have a derivative of a function of x times another function of x. And so what that says to me is product rule, right? And so I tried this out on a blackboard, and I was like, wow, this is really awesome. So let's try it. Let's try it. So product rule, right? Which is another mysterious formula. So I guess we're proving a mysterious formula with another mysterious formula, but let's just see what happens here. So I'm gonna, where do I put all this stuff? I'm gonna put this up here. So the product rule says we take the derivative of the first times the second plus the derivative of the second times the first. Now, I think he has a great video, and I will link it in the description as well, about the origin of the product rule. And it has something to do with areas, and you have something like x times x, and you look at the little increase of area, and it turns out that this is negligible, and somehow x squared, the derivative, turns into 2x. But I will leave that to the master himself, and we will just use the product rule as a given to show the origin of the quotient rule. So this is the first, this is the second function. So we'll do the derivative of the first, which is f prime, times the second, which is g of x to the minus 1, which is also 1 over g of x, right? Plus the derivative of the second. Now the derivative of the second is going to involve a few things, the power rule and the chain rule. So let's do that over here. We'll say the derivative with respect to x of g of x to the minus 1 power. Well, first of all, we have this power out here, so we're going to bring the power, the number down out front and decrement this by 1. So we're going to raise to the minus 2 of g of x. Then we have to take the derivative with respect to x of the inside. This is the chain rule, and multiply. So that's times g prime of x. So the derivative with respect to x of this g of x to the minus 1 power is negative 1 over g of x squared, or g of x to the minus 2 power times g prime of x from the chain rule. So right now this should be setting off alarm bells, this minus 1, and this should be setting off alarm bells, this minus 2, as the bottom squared, you know, that little jingle you remembered to remember the quotient rule. So let's go back to the product rule. It says the derivative of the first times the second plus the derivative of the second, which is this whole thing, minus 1, we have over g of x squared times g prime of x times the first. You have to remember the product rule, right? Times the first. So this whole thing up here is equal to this. Now with some simplification, I think you'll see your old familiar friend, the quotient rule. So we'll leave this first part the same, f prime of x over g of x. And we'll bring this minus out front. And we'll bring this stuff here up top, g prime of x, f of x over g of x squared. Now, two fractions, let's get a common denominator. I'm just going to multiply this left-hand side by 1, or written another way, 1 can be thought of as g of x over g of x, right? Something a over a, b over b, whatever this number is, divided by itself is 1. So we'll multiply that. And by doing so, we can combine the bottom and just get g squared and keep the top up there. Sorry. G of x times f of x over g of x squared. And look at that, f prime g minus g prime f over g squared. And I'll just write it out. We'll combine these fractions. So I'll just center in on here. We're going to need just one of these, g of x squareds. We can move this minus up here, g of x squared. Lock this in. And I think I had the order of these swapped, you know, so we can just and this, if you remember, is f prime g minus g prime f over g squared. This is the quotient rule. So the origin of the quotient rule is really thinking of f over g as f times 1 over g, and then the derivative of this entire thing is the product rule, and the derivative of this is the power rule, and then the chain rule. So I don't know how obvious that is to all of you. I'm sure my Calculus 1 textbook explained this, but for some reason, you know, you're rushing through the material and you want to just remember what you have to remember to take derivatives, and you don't step back to see the origin of some of these formulas that you have to remember. And so I was just blown away when I saw that, and I thought, oh, okay, that's where this formula comes from. So anyways, I'm glad to start making some more videos for you guys. I know it's been a while. I've been going through Calc 1, and now I just did an accelerated Calc 2 class, and so we're off to Calc 3, multivariable vector calculus, and I think that's going to have a lot of applicable material for this channel, especially neural networks and machine learning. So I hope you guys forgive this kind of off-topic video, and maybe give me some feedback on whether you like this type of video making, as I just scribble here, you know. But anyways, I want to thank you guys for all your support, all your awesome comments, and I will see you guys in the next video. Thank you very much.